Hello, everybody, and welcome to MS-DOSX for this week. At the end of this week, this is going to be a pretty short lecture. This one's mostly hands-on. Another reason why this one is short is that certain key elements in here I was demoing in the past. The problem now is that we're about half Xcode 3 and half Xcode 4. This has changed quite a bit since Xcode 4. So there'll be instructions for the lab. We have two sets, one for Xcode 3 and one for Xcode 4. You're welcome to use either one. However, the lab machines have Xcode 3 only. So this is just going to be a really pretty short lecture. Tonight's topic is going to be about testing and unit testing with Xcode 3. So previously, the slides and the lab all referred to Xcode 3 only, Xcode 3 only functionality. It's no longer like that, so I've fixed up most of these slides. There may still be a couple of bugs left in there, and I'll fix those as soon as I can, and we'll make sure that the one that's up on the website is the most current, is the latest one. So there'll be times when we can look at these together, look at OS 10 and iOS apps together, and there's times that we will have to look at them separately by the way that we test them. For the most part, however, if we look at unit testing together under Xcode, we look at both OS 10 apps and iOS apps. And there's two basic categories. There's the logic category, which is done at logic category of testing, which is done at build time or compile time, and then application tests that are done at runtime, or dynamic testing, which is more akin to like the assertion code that we talked about last time, or the previous lecture. There are ways to automate the testing. There's built-in ways to automate much of the unit testing when it comes to logic and application tests. When it comes to input and UI testing, however, there's big differences between Xcode 3 and 4, and we'll talk about that in a second. So why do you test in the first place? What's the payoff? What's the gain for actually putting some time into testing in the first place? Well, number one, obvious one, healthier software, that your programs are more robust and less likely to crash. It gives you a sense of confidence when you update your code that you're not going to start breaking things down the road. Designing improvements into your code also makes you aware of API problems that you may be presenting to not only the user, but also to other developers who may be using your source code. This includes yourself a year later when you come back to your source code. It's much better if you've been forced to use your own API, and you will find yourself generating better and better APIs for yourself to use. From the get-go, you'll be more confident and comfortable in generating APIs that are usable for you, as opposed to slapping them together, getting them to work once, and then not looking at them again until something goes horribly awry later. The other nice part about testing too, and especially unit testing, is that you build a real solid foundation for the rest of your application to be built upon. As you know, the weakest link is going to be the downfall of your application, and with iOS apps, a lot of times that manifests itself by your app just quitting, and with no warning, and just quitting. And oftentimes that also results in loss of data, and if that happens once or twice with a user, they're never going to use your app again, and they probably won't use any apps that your company designs again either, because it's pretty indicative of not having had a lot of testing go into it in the first place. The other really nice thing about testing too, and unit testing, is that you basically self-document your code when you build your unit tests. Not only do you comment your code as you are writing it, but just just the sheer fact that you've got your API calls and what they look like and the order that they go in and what is expected to go in and come out gives the user, including yourself, of your frameworks or your API a really big head start in getting the functionality that they want out of it, rather than having to go through line by line and try and figure out exactly what functionality your API provides to them. And then this one's also pretty obvious. A lot of people think, oh, why am I going to add testing? It's going to add a lot of development time. And study after study after study, I shouldn't even have to tell you this, that study after study has shown that the more testing that goes up front into code, the higher quality and more code you generate overall. So some differences between OS 10 and iOS testing. They both can do logic testing, which is the testing at build time, as well as application testing or runtime or dynamic testing. On Xcode 3, application testing for iOS devices is on you have to run it on the hardware itself. And we'll talk a little bit more about this in a minute when I get to iOS specific stuff. So dynamically testing your iPhone app has to be done on the hardware. There's advantages and disadvantages to it. One of the big disadvantages is that you have to run it on the hardware. So you have to constantly keep building and transferring your application over. On Xcode 4 now, however, since this was such an obvious Achilles tendon, Xcode 4, you can actually run your application or your runtime or dynamic testing within the simulator on Xcode 4. It's almost identical functionality in the APIs for OS 10 and iOS. So a lot of this stuff that I may talk about specifically for OS 10 also translates to iOS development as well. So OS 10, for the application testing, for runtime testing, you typically start by testing your model. The nice thing about having to test your model is that you usually don't have to have any interface on your model. In fact, if there's an interface on your model, you've done something wrong. Because remember, we're trying to put everything in the MVC design pattern, the model view controller design pattern. So your model should be entirely independent of your view. So therefore, one of the benefits of MVC is that you're able to test your model in a sandbox. You should be able to test your model, your functionality, your underlying functionality and data handling code without having to worry about your interface. Testing the interface on Xcode 3 is pretty tough. It's pretty challenging. We'll talk about that in a second. So for iPhone, for iOS, the logic and application testing. The logic tests are the logic tests that you write that are typically for your model are run and built, and the output of the tests is given to you at compile time, at build time. So it's done even before your application is running. One of the nice things about that is for Xcode 3 is that you don't have to have your logic tests running on the actual hardware. It's also really nice because you don't have anything about the iPhone the iOS device's state that won't interfere with your logic testing. You'll be able to run it basically in kind of a sandbox mode where it's impervious to outside influence, and you can test at a very highly granular level. You're able to test your API and your functionality at a very particular level that you can't do when you're running it on your hardware. The application tests that run the tests that are run at runtime, the dynamic testing. One obvious benefit to that is that you can write application or runtime tests that utilize specific types of hardware, like the location sensor or the accelerometer. So I'm going to just really briefly go over these steps. This is what you guys are going to be doing today if you're setting up the project with Xcode 3. Xcode 4 has a much simpler process in setting up unit tests. For Xcode 3, however, you basically create a new target to run your tests under. What you'll be doing is adding a bundle to your application, and it's a unit test bundle. It's actually a specific type of bundle. You'll see that in the drop-down menu when you can select what type of new target you want to add to your project. You'll see references to OCUnit a lot. This was the primary framework that the unit testing, Xcode's unit testing comes from. It's been renamed, and it's now the Send Testing Kit, the Send Testing Kit framework. It's buried pretty deep. For Xcode 3, it's buried pretty deeply in the library frameworks pathways, developer frameworks, library pathways. It's a bit of a hassle to get to, so I'll show you some tricks on how you can do that in Xcode 3 in just a second. It's also really helpful to create a new group within your project. Remember, groups, the group folders within your project are just a way to organize your files. It doesn't create actual folders. It doesn't change your actual source file hierarchy in the Finder. So it's really convenient to group all of your tests together and subgroup those with logic tests or application tests. Then you're going to create every new test case that you create that you want to run. You'll be creating a new file, and that new file type, if you look, there's actually, if you've previously seen create new Cocoa object file, or create new zip file, or create a new C++ or .m or .h file. There's actually a create unit test case class. When you use that, it will have the correct imports and the correct overridden class all set up as template code for you. And you're going to get some practice with that in the lab. When you build the target, this is for logic tests. When you build the target, the output will be in the debugger console. It'll show you how many of your tests ran, how many of them were successful, which ones failed, and at what lines they failed. So you can set up your logic tests for OS X and iOS to a certain degree. You can set them up to be independent of your regular build process or dependent on your build process. There's pros and cons to both setups. The pro to having them independent is that they're easier to set up, and you can run your tests only when you want to run your tests, not every single time you build, which can increase your compile, build, run, debug cycle. That you're going to have to weigh against the benefits of continuous testing, especially as you're writing new code. And that, which falls right into the con category, you do have to actually run it manually. And oftentimes when people, especially as they run up against a deadline, test code generally stops getting run at all by that time. So you can make your build cycle, your build of your application, dependent upon those logic tests passing. And you'll see that in the lab. What's really nice is that it runs the tests automatically when you build. You don't have to do anything special when you set it up that way. It still lets you build the main executable separately, so you don't have to worry about a bunch of test code being involved in your application, your final application bundle. It requires a couple additional, well, let me actually, I need to amend this. It requires a few additional steps to set up an Xcode 3. It requires very few steps to set up an Xcode 4. Xcode 4, you'll notice once you switch, or if you've switched, has got a lot of the unit testing built in from the ground up. Apple took unit testing very, very seriously for good reason, and has made it much easier to integrate unit testing within your edit, compile, build, run, debug cycle. So ahead of time, start anticipating what kind of logic tests you're going to need and what kind of application tests you're going to need. You are going to need some test cases, and for homework you must have some test cases. So start thinking ahead of time. What is a logic test? What is something that I can test independent of the views? What's something that I can use to test my model, my functionality code? This includes not only your Objective-C models, but also your C++ classes and methods that maybe you're integrating in with the project, even the C methods and applications that you're integrating in your project, versus tests that need some form of dynamic runtime environment to actually make sense, such as if the user has touched these two buttons, or if this window has come up and shown itself and then a drawer has opened and then the drawer is closed, what happens to the values that were contained within that drawer, blah, 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 blah. So all of anything that's dynamic, anything that has to have some setup that your application has to run will be a dynamic test. So both tests in Xcode 3 are new targets, but the application tests, since they're woven in, they're locked in with your application, the runtime, your dynamic application runtime in and of itself. They're not going to be sitting separately from your application like your logic tests are. This actually will make a whole lot more sense when you get some hands-on work with this in the lab. So for iOS devices, the logic test setup is the exact same thing that you do for OS 10 applications. Just make sure that you select the iOS classes and not OS 10 Cocoa classes. That I do that constantly most of the time because it's defaulted one way or the other. It'll let you go ahead and add it, but you'll start generating some really strange errors that if you start seeing errors along the lines of NS blah 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 not found, or NS, this NS type not found, or this header NS header is not found, that's a really good indicator that you're using a Cocoa class instead of a touch class, an iOS class. So application testing, dynamic runtime testing for Xcode 3 on iOS devices, you're going to basically make another copy of your application. You'll make a target application that's actually independent of your final release build application. You'll add the unit testing bundle target to that iOS application, the testing application project. You set up a dependency so that it will copy your application into the your final application in and run your testing code. Under Xcode 3, it only runs on the device. You have to run it on the hardware. It doesn't run in the simulator. The output, any output will appear, any output from the tests that are running on the iOS device, if there's failures that happen, will appear in the debugger console on Xcode 3, where all of the other test unit testing output goes. So the test class, you inherit. Who's familiar with JUnit? Who's used JUnit before? Okay, so it's very similar. It's based on a lot of the same class hierarchy. You inherit from send test case, this class. Your methods of this class are your test cases. When you add an Objective-C test case class, it gives you a template. It imports the correct header file. It gives you an interface that subclasses from send test case. All of your tests, to have automated tests running, tests that you don't have to call yourself, they need to begin with the word test. They take no parameters. These are all methods. Remember, what's nice about Cocoa and Objective-C is that you can dynamically query an object about what kind of methods it can handle, and that's basically what happens here. The Send Testing Foundation Framework goes in and looks at your test case object and figures out which methods it has that are prefixed with the word test, that don't take a parameter, that the return type is void, and it will automatically run them and give you the output of whether they succeeded or failed. Basically, this is what the interface looks like, and you declare this is where you're declaring the test method. This is, for instance, this is our test 1. In the implementation, very simple. Returns a void, doesn't take any parameters, begins with the word test. I should make this agree with the interface, but test case 1 and any of your test code goes in there. So there's a ton of macros that have been set up and are available for you to use for your testing. The general outline of these is to either handle an object or an expression and compare that to some value or check to see if it's false. Like in this first case, assert not nil takes an object and is basically just checks to see if it's null or not. If it is, then it will use the next parameter in part of its output and generate a failure, a test failure, and then use the description, which is an NS string, followed by a variable number of arguments, meaning that you can use, it's really kind of handy, actually it's very, very handy, you can use printf style formatted strings in your description. So you can say, this object was null. This object of the array, %@ array is null, and then pass the array in and pass any other parameters you want in. It's variable length, and it will spit that description out all nicely formatted. True, false, obviously. Check to see if the objects are equal to each other. Check to see if the equal objects and equals are different. It's up to you to figure out how they're different, and it's a really important reason why they're different. Assert throws we'll check to make sure that you are throwing exceptions, and we'll talk about that in a second. Same thing, expression, just like before, and description for like a printf formatted string, and then any number of arguments passed there. There are a ton more of these macros that are helpful, handy macros. The full reference you'll have a link to it on the lab, and it's not under that. It's there at the front page. Questions so far? So this is a little kind of hand wavy overview-ish, because you're going to get a lot of very hands-on, like step-by-step instructions on using the testing framework and the benefits of using the testing framework. So some of the questions that may be kind of rattling around right now, see what happens during the lab. If you're still confused about things, make sure that you ask us here or ask us on Piazza. So automating UI events and I should specify under Xcode 3 is actually quite a bit more involved. You use the instrument automation tool, and you have to write a JavaScript test file that will actually go and press elements or slide or add text to elements in your user interface. It's not trivial for Xcode 3. We're not going to be doing any of that. There's a lot of online references, and I think I'll probably need to add a few links to the lab page, but there are some pretty good links on how to do this. I highly recommend it because it's a great way to test your interface, but with Xcode 3, it's definitely not trivial. The UI automation reference collection is where you find out how to automatically test your user interface. It uses, like I said, the instruments, built-in instruments, UI automation. This is Xcode 3, by the way. And then O'Reilly Books has a tutorial on generating the JavaScript to use UI automation to test your user interface on your iOS device. So, writing testable code in the first place. Figure out what your API requirements are ahead of time. Don't start immediately banging out code and then go back and decide, okay, well, I probably need this functionality and I probably need this functionality and maybe I could add this functionality later. Define your API requirements ahead of time. Figure out what your inputs are, figure out what your known outputs are, and figure out what your exceptions are. What should generate an error and what shouldn't. How should you be handling your errors? Make sure that you're consistent and make sure that you're testing each one of those cases. Write test cases as you code. Who's heard of test-driven development, agile practice, test-driven development? In a nutshell, basically says that you write test cases first, then you write the code that makes those test cases pass. You write the minimum amount of code that you need to make those test cases pass. So as you're writing your test cases, you're writing very minimal code to make them pass. Initially, they're just stubs. It just returns back exactly what you're looking for. Is this equal to this? You always return true. Great, that passes. Now I want to test to see that if I call is this object equal to another, returns false. When I pass it two different objects, you write a test for that. You pass in two different objects, it's returning true. You need to go fix that code. So you write the minimal amount of code to get both those tests passing. You keep iterating like that and refactoring your code like that. So you're testing all along. This is shown to produce incredibly bulletproof code. And in fact, a lot of large software projects that are begun nowadays are primarily test-driven. The development is primarily test-driven because there's so many advantages to it. Make sure that you test your boundary conditions. Make sure you're checking inputs that are within and just without the acceptable ranges that you're looking for. Let's say you've got an array of 100 objects and you're writing a function to get like an object at index function. Or method or message that you are going to be passing an array or a collection, and you're going to be getting an object out, and it's from 1 to 100. So you test 0, test 50, and test 100. Test your edge cases. Make sure those work. Then test -1 and test 101. Make sure that you are testing that you are failing correctly. Does that make sense? So make sure that you test that make sure that you check that you're not only testing for when your code works correctly, which is usually very easy. Make sure that you are also testing that your code catches errors correctly, that it fails correctly. Check your exceptions. It's all set up so that you can catch exceptions. So be diligent in making your code throw exceptions under well-defined cases that your API documents. Write really comprehensive test cases. So unit testing, a lot of people get bogged down in minutia, in testing every single method of one class, and then testing every single method of another class and saying, okay, cool, I got all my tests, it's test-driven development, and everything gets tested. Well, not quite so much, right? Because a full-fledged application is an interaction of a lot of different objects. So start layering your tests. Make sure that each one of those methods work, but if you have an interaction between, say, your model and your view controller and your view, make sure that you test that comprehensively as well. Make sure that you can if your view is asking for something, and if it goes through your controller and goes to your model and comes back, make sure that each one of those steps along the way, make sure that each one of those steps works, and then make sure the entire step works all together, comprehensively. An example that they give, that Apple gives, create an array, fill it full of objects, remove a few, ensure that the array's contents are exactly what you expected. So instead of testing the creation and then testing fill and then testing remove, you can test those individually. Those are pretty well documented and work as advertised. What you want to see is the end result of all of these operations happening together. When you have a bug fix, write a test for it. So even if you don't write a test, even if you're not doing TDD, if you're not doing test-driven development, if you find a bug in your code, write a test case for it and then fix it. Or fix it and then write a test case to make sure you fix it. Trust me, this comes back as a huge benefit when your tests start catching what are called regression bugs. When you start adding code or adding functionality or change or refactor things, some bugs can creep back in again that you had squashed previously. Writing test cases while you're bug fixing is an excellent way to catch regression bugs. And I can almost guarantee you that it's going to save you hours and hours of time if you do that. So today's lab are basically comprehensive instructions for Xcode 3 and Xcode 4, step-by-step instructions. There are no associated notes. You can download the projects that if you have trouble finding them in the documentation, they should be there. But you can also download them directly if you Google them. There's a full ST, like ST assert not nil, ST assert true, ST assert false macro reference link within the lab. There's also some additional information in there, including the UI information. Homework, first homework. So your homework for next week, next Friday, by the end of the day next Friday, is to write test cases for either Bouncy or Bouncy iOS, or something that you've done previously in lab, like asteroids, or something that you would like to write in the future, like your project, or some project that you are just building just for the sake of testing that you can chuck, that you don't necessarily need. So a full comprehensive test coverage of something, of asteroids or Bouncy or your own idea for a skeleton idea for a project. Show that you know how to use the testing framework. This is really, really important stuff, and this will actually, the time that you invest ahead of time in learning how to do correct testing, especially with Xcode 3 and 4, I can guarantee you, will save you hours and hours and hours and huge headaches later. All right. Questions probably will be answered in the lab. So we'll be circulating around as you go through them. I think Kevin is putting the lab up right now. So get started.